To solidify some of these concepts in graphing a quadratic, let's go ahead and do another example. So here's our next example. We have the equation y equals negative x squared plus 6x minus 3. Again, the very first step is to find the vertex. So to find the vertex, we know that the x-coordinate of our vertex is simply negative b over 2a. Well, my b value is 6, and my a value in this case is negative 1. The 1's not there, but the negative is, so we have to do negative 1. So negative b over 2a, b is 6, so negative 6 divided by 2 times a being negative 1. So negative 6 divided by negative 2 is what that becomes, and gives us a final answer of the x-coordinate of our vertex being 3. So now we have the x-coordinate of our vertex here, which is 3. So we can start working with that now. Well, we can use the x-coordinate of our vertex to now find the y-coordinate of our vertex. Again, hopefully we remember that to find the y-coordinate of our vertex, we simply take what we got for the x-coordinate, which in this case was 3, and plug that into our function. Now we've got to be careful here because the 3 goes in for the x value. So at the very beginning we have negative, and then I'm going to write it as 3 squared because the negative is not getting squared, only the 3, plus 6 times 3 minus 13. This produces for us that the y is equal to negative 9 plus 18 minus 13. Well, negative 9 plus 18 is positive 9. Subtracting 13 gives us negative 4. Gives us negative 4. So now that we have our vertex of 3, negative 4, we want to go ahead and plot that point on our coordinate plane. So the point 3, negative 4 is over at 1, 2, 3, negative 1, 2, 3, and 4. 3, negative 4 is this point right here. So we've got that labeled, and just like the example we did before, the next step after finding our vertex is to build a t-table around our vertex. So here's our xy t-table, and in the middle we're going to put the point 3, negative 4. And again, we want to pick 2 values on either side, 2 values minimum, on either side of our vertex x value. So I'm going to pick 2 and 1, and 4 and 5, again keeping it nice and symmetric so that I can calculate just half of them and then mirror the y values over to the other x values as we did in the previous example. So let's start here with negative 1. Plugging negative 1 into our function above. 1 squared is 1, then there's that negative on it, so negative 1. 6 times 1 is 6, so negative 1 plus 6, and then minus 13. What does that produce? Negative 1 plus 6 is 5. And then if you subtract 13 from that, it produces negative 8. So when we plug in 1, we get a y value of negative 8. Next, let's plug in our value of 2. So plugging in 2 for x, we end up with 2 squared, which is 4, but then we have that negative on it, so negative 4. 6 times 2 is 12, so that's negative 4 plus 12, and then the minus 13 at the end. And what does that equal? Well, negative 4 plus 12 is positive 8. When I subtract 13 from that, I end up getting a negative 5. So when I plug 2 into my function, I'm ending up with a y value of negative 5. Now again, this is nice. We're going to save half the work because since the value of 2 is the same distance from the vertex as 4, just on the different side, because parabolas are symmetrical, we know that if we were to plug in 4, the y value we would get out is -5. And likewise, because 1 and 5 are both the same distance from my vertex, the x-coordinate of my vertex, they're both 2 units away on either side. I know that since I got -8 for my value of 1, x value of 1, I know that I'm going to get -8 for an x value of 5. So with our t-table completed, we can now plot these points. So 1, -8. 8 is this point right here. We have 2, -5, which is right here. We've got 3, -4, which is our vertex already plotted. We have 4, -5, which is this point here. And lastly, we have 5, -8, which is this point here. Again, nicely lines up in the shape of a parabola for us to connect. And as we connect these dots to get our parabola, what we'll notice is that it opens down instead of up. It's a little different than the previous example, but it is what we expected. Our value of a up here in our equation y equals -1x squared plus 6x minus 13. The value of a is -1, less than 0 from the chart we saw on the first page. If our a value is less than 0, our parabola opens down. Now there's a couple housekeeping things we need to do with this parabola. Number 1, label the vertex. Labeling our vertex here, that's 3, -4. We also need to label 2 other points. I'll go ahead and label this point, that's 4, -5. And I'll label one on the other side over here. I'll label this point over here, which is 2, -5. Okay, and last but not least, we need to label our vertex. Not our vertex, sorry, our axis of symmetry. So to do that, we know that the axis of symmetry is a vertical line. Oh, let me undo that real quick. It's a vertical line that goes through our vertex, right there, and splits our parabola in half so that each side is a mirror image of each other. The last thing to do is label label the axis of symmetry. And we know that the equation of a vertical line is x equals, and then wherever it crosses the x-axis. In this case, it's at 3. So x equals 3 is the equation of our axis of symmetry.